Can see my slides? Yeah. Okay. Seems like there's some problem with my laptop. So if let's say any point of time you can't see the slides moving, you got to let me know. Thank you. Okay. So what happens during chemical reaction? Now, atoms actually move, but they move in certain way. Okay, so what is it that is happening for the atoms is, okay, let's see, you already know, right, the mass of the reactant must be consistent with the mass of the products. I have said before last lesson, what goes in must come out. Okay, so whatever that goes in cannot disappear. It has to come out in maybe other forms. Okay, so you need to take note, okay, whatever comes out must be what has entered into the reaction also. You can't have products that are totally different or some foreign stuff coming out and you don't see them in the reactants at all. So whatever you receive must have been reacted together with other substances, okay? So example here, sodium metal reacts with chlorine gas to form sodium chloride. Okay, so this is the sodium chloride that you're looking at. When you write word equation, we practiced a little bit last week, right? Sodium plus chlorine gives you sodium chloride. You only need to know up to this level. You also need to know this, atoms cannot be created nor destroyed, okay? And then in every chemical reaction, the mass of the product must be the same as the mass of the reactants. So the atoms of the reactants actually rearrange themselves. Okay, they rearrange themselves to form new products, right? For example, sulfur and oxygen combine to form sulfur dioxide. Okay, yeah, so if you want to take a look at what is happening, is basically the element sulfur combining with oxygen gas. Okay, you have to heat up this reaction and what you get is definitely, you know, the same as what you have put in, something that consists of sulfur as well as oxygen. We call it sulfur dioxide. If you want to look at the molecules, okay, so this is how they look like, atoms and molecules. Sulfur exists as single atom. We call it monatomic. Monoatomic. Mono is one, okay, atomic refers to atom. So monatomic means one atom. Oxygen exists as diatomic molecule. We talked about this last lesson as well. I did mention the diatomic molecules like oxygen, hydrogen, fluorine, chlorine. Okay, then upon heating, the rearrangement goes like this. If you can see, okay, I'm just going to explain a little bit more to you. Okay, so what happens is there is actually the energy that is put into this molecule to separate the atoms. So from the molecules, they become atoms first, then they rearrange, they rejoin. Okay, now you see the bonding is here. Can you see the bonding is here? Rather than just now oxygen is combined with oxygen. Okay, there's a chemical bond between them. Now it is like broken up and then rejoined together with the sulfur to form sulfur dioxide. If you were to count, okay, one sulfur atom reacts with one oxygen molecule. This oxygen molecules consist of two oxygen atoms. Whatever comes out is a sulfur dioxide molecule, but this molecule consists of two oxygen atoms and one sulfur atom. So whatever goes in, which is the one sulfur atom and two oxygen atoms, is also coming out after the reaction. Just one sulfur and two oxygen. Can y'all see that? It's always this case. Okay, it's always this case. Whatever goes in must come out. So the mass must be equal. Yeah. So the key here is just showing you, okay, this circular thing, which is light blue in color, represents sulfur atom, and then oxygen atom is represented by a silver circular thing. Yeah. All right. So what, like I explained to you earlier, right? Okay, the oxygen molecule is split up and rearranged so that each oxygen atom combines with the sulfur atom to form a molecule of sulfur dioxide. You are going to learn a little bit more when you go higher level, even in JC, let's say you're learning A-level chemistry, then you are going to learn about bond energies and so on. Yeah, so that is the part where you have to do some calculation. Right now, it's as simple as what goes in must come out. Bonds break, right, to form new bonds. So in this case that I mentioned to you, oxygen molecules split up, the bonds here, okay, the bond here is broken, then new bonds are being formed. Okay, the new bonds are being formed. They didn't say bonds because you only learn chemical bonding in Sec 3. Okay, so if you were to look at the number of sulfur and oxygen atoms, they remain the same before and after the reaction. They are always the same. So during combustion, okay, carbon actually burns in oxygen, right? So this will give you carbon dioxide. Similarly, it's going to look like this. Carbon is monatomic, so single atom. Oxygen exists as diatomic. So what happened again, as you can see, okay, the bonds here for the oxygen will break, then new bonds will form. All right, so one carbon atom with two oxygen atoms, okay? Eventually, what comes out in the product is also one carbon atom, two oxygen atoms. So far, so good. Very simple, very direct, right? Yeah. So this is straightforward. Okay, so the number of carbon and oxygen atoms stays the same, right? It's just that the atoms rearrange themselves to form new products, new substances. So take note, atoms are just rearranged, they are never destroyed. Okay, you cannot form new atoms. It's always the same atoms, just new products, new molecules. The mass of the product is equal to the mass of reactants. Okay, so very simply, this is about it. But when we see questions, we can see something maybe more difficult. Okay, like I think if you want to explore further, let me get you to think about nitrogen plus hydrogen to form ammonia. This is a reaction that you might want to consider exploring, okay, because nitrogen looks like this. It is diatomic, same as hydrogen, okay, diatomic also. So bonds will break, right? Bonds will break, and then new bonds will be formed. Ammonia is NH3. So right now, you'll be thinking, how come when I start counting in the reactant side, right, I have two nitrogen atoms, right? And then I have two hydrogen atoms. But what is being given out or what is being produced in the reaction is one nitrogen atom and then three hydrogen atoms. So you start thinking, 2 and 2 makes 4, right? So there are 4 atoms in the beginning, then 4 atoms that's produced at the end. Is it right or wrong? Can I leave it like this? The answer is cannot. This is not correct because we must ensure what goes in have to come out. Okay, so how will this be resolved? Okay, remember, a chemical reaction represents the reactants reacting together to form new substances, the products. They must react in certain ratio. It is the same like cake making. Have you all baked any cakes before or cookies? How about you did? How about Unluck? Have you tried? Have you tried baking before? I think in FCE you must have tried, right? Yeah. How about Halun? Did you try? Your teacher will give certain recipe, right? Then you just follow. So this is like a recipe. Whatever you put in to make a cake, for example, teacher say 1 egg to maybe 1 cup of flour, okay, and then 3 tablespoons of sugar to a certain amount of water. So you always follow the same ratio to produce one cake, right? So in this particular case, if I want to make sure this equation works, I must make sure also the number of atoms that goes in for each type of element will be the same as whatever come out, right? So this is what we call balancing equation. So the process is known as balancing equation. Eventually, what you get will be a balanced equation. So now I have to start looking at this again. Now, 2 nitrogen atoms going into the reaction. I cannot have just 1 nitrogen being produced. You agree or not? Cannot be. Then you know that whatever comes out must be ammonia. So I can put in 1 more ammonia first. That will actually satisfy the 2 nitrogen inside the reactant. Correct or not? But now, okay, so I have 2 nitrogen atoms. How many hydrogen do I have now? Instead of 3, now I have 6. Correct? So is this a problem? Yes, it's still a problem because now the number of hydrogen atoms is not the same. Right? So what do I do? Don't start to panic. You just start thinking. Here I have 2 hydrogen atoms, right? Hydrogen exists as diatomic. So hydrogen will say, okay, never mind. I have more friends coming in. So now I have, okay, 3 hydrogen molecules that will give 6 hydrogen atoms. Correct or not? So does that already satisfy the whole equation here? Is it a workable reaction? Yes, it is. But you only do this in Sec 3 most of the time. But I have seen questions coming out in Sec 2 where they get students to figure out, because you learn that the atoms cannot be created nor destroyed. Whatever goes in must come out. The equation will only work if the mass of the reactant will be the same as the mass of the product. So students are asked to figure out how to balance it lah. Okay, but they don't know that they are actually doing something that they were supposed to learn only in Sec 3. Yeah, so those are the application questions that will come out maybe in Section C. Yeah, the tougher questions. All right, so Section C, not the entire question will be difficult. It's only a certain section. Clear? So these can come out. So just to prepare you for it. One example here. Now, next one, very quickly, is about how chemical changes affect us. Is it going to be good for us or is it going to be bad for us? Of course, some reaction will be good. Okay, like photography, it helps us, right? We can have some pictures being taken and then it can be kept for memory's sake. Of course, some chemical changes are not good. For example, decomposition of the food that we are eating. When the food is left on the table unattended, the chemical change leading to decomposition of part of that food, right, will cause us to be sick if we were to eat that food. Okay, so examples like these you need to know. Okay, here they talk about higher level industries, power station industries releasing sulfur dioxide. Okay, this is going to give us a lot of problem. Why? It forms acid rain. Right, so acid rain destroys forests by killing trees in large numbers. In Sec 2, I think, or even in Sec 1, have you learned already air pollution and stuff? P6 definitely learn lah. Sec 1 in geography, they all learn about this. Your deep projects, right? Water also, water pollution and all. Okay, so this is similar. It's just added knowledge, repeating what you have learned in other areas also. Like geography, you learn already. In primary 6, you learn already man's action. Man's impact on the environment. Right, so benefits of chemical change. We can use heat to cook our food. We can use heat to even heat up the food such that it can be preserved. Like the jams. Okay, jams are formed when you actually, maybe you talk about strawberry jam. You cook the strawberries and then you add sugar, then you can it. Yep, so you can preserve food that way. Right, decomposition, when let's say animals or living things die, decomposers help to decompose the dead organisms, break them down, and then return the nutrients back to the earth. This is what you need to remember. Decomposition, Miss Tay mentioned just now, can be bad, but there are good sides of it. Household detergent,